Hi, let's talk about linear inequalities. A linear inequality, first of all, you need to make sure it's linear because quadratic and higher degree inequalities have to be treated much differently. But as long as it's a linear inequality, then it works exactly the same way when you're solving it as a linear equation with one difference. Now, by a linear inequality, I mean something along the line of where your answer is going to come out to be something like x is less than 3. This means that any number smaller than 3 could be x. And we would mark that on a graph like this. Anything smaller than 3. I'm using a parenthesis because 3 is not an answer. 2 is an answer. 0 is an answer. -10, any negative number is an answer. 2.9999999, etc. is an answer, but not the 3. If we write this in interval notation, since the lower limit here is -infinity, in interval notation, this would be written from -infinity to 3 with parentheses on both ends. On the other hand, x is less than or equal to 3 would be represented on a graph as all the numbers below 3 or including 3 itself. And to show that, we put a bracket on the 3. In this case, 3 is an answer. In the first one, 3 is not an answer. In interval notation, this would still be represented with a parentheses on the -infinity, but with a bracket on the 3. The other possible versions would be x is greater than 3, where x could be any number above 3, but not 3 itself. So it'd be from 3 to positive infinity, or x is greater than or equal to 3, in which case it would still include the numbers greater than 3, but in this case 3 itself would be a potential answer, or not potential, an actual answer, and we would use a bracket on the 3. If you ever forget which direction this means, notice that as long as the x is on the left side, that this matches up with this, and this would match up with that. So it tells you, this sign tells you whether you should move to the right or move to the left from the 3 is kind of how I look at that. Now, the one difference between solving a linear equation and a linear inequality you still want to always remove parentheses or any type of grouping symbol. So that's going to be done usually by distribution. You want to clear your fractions by multiplying both sides by the common denominator. You want to sort your terms. Oh, sorry. You want to sort your terms. And by this, I mean get all the like terms together on one side, the variables on one side, and the non-variables or the constants on the other side. And then you divide by the coefficient. Now, this is where there is a slight difference that could occur. If I had, let's say, 2 is less than 3. Everybody agrees with that, right? If I add 2 to both sides, if I say 2 plus 2 is less than 3 plus 2, then I've got 4 is less than 5, which is still true. If I subtract, then that's just going to put me back where I was to start with. So adding and subtracting works the same as before. If I multiply, say, by a positive 2, if I say 2 times 2 is less than 2 times 3, then you can see that this is still going to kind of come out true. But if I were to multiply by a negative 2, if I said negative 2 times 2 is less than negative 2 times 3, now I get negative 4 is less than negative 6, which is false. Because as you can see, whereas 4 is to the left of 6, so this is true. Negative 4 is to the right of negative 6. Therefore, negative 4 is the larger number. Got a problem here. In an inequality, if we multiply or divide by a negative number, we have to reverse the sign. In other words, take this sign and rewrite it so that it points the other direction. So for example, let me work one both ways. If I had 2x plus 3 is greater than 5x minus 4. I don't have any parentheses, so that's done. I don't have any fractions, so that's done. So I just want to get my x's on the same side and my constants on the same side. So I could subtract 5x from both sides. That'll take care of that. And I could subtract 3 from both sides. That'll take care of that. So I have negative 3x is greater than negative 7. But when I divide by negative 3, I need to turn this sign around. And I always go up and circle that sign because otherwise I will forget when I get involved in the math in the next step. So this turns out to be a positive x. This tells me to turn that around. This ends up as a positive 7/3. I could have made the choice. Let's look at the same exact problem. I could have made the choice to put the x's on the right by subtracting 2x. And then I would need to add 4 to both sides. So here I would add up with 7 is greater than 3x. Now I just need to divide by a positive 3. I don't turn the sign around because it's a positive 3. Now this has nothing to do with what the answer turns out to be, only with what we're dividing by. So this gives me that 7/3 is greater than 1x. But if 7/3 is larger than x, that's the same thing as saying, well, then x must be smaller than 7/3. So notice the result is the same in both cases. And if I'm going to graph this, I would just take my 7/3, put a parenthesis, and it goes to the left. If I'm going to put it in interval notation, since this is negative infinity down here, it would be negative infinity 7/3. And since it does not have the equal sign, it's going to be a parenthesis. There's no equals on here. So I want to use parentheses. Now, if we flip back a page, this is an example of an inequality word problem. John needs to rent a car this weekend. One company charges $10 per day and 35 cents per mile. A second company charges just 55 cents per mile. For what mileage would the second be better? Okay, better depends on whether, when it comes to money, whether you're on the paying out end or on the receiving end. I think everybody would realize, since John is going to be paying the bill, that better in this case is going to be when the second amount is smaller than the first amount. So the second company, didn't mean to do that. The second company, this is in dollars and this is in cents. So we need to get both of them in the same units. So let me say that the second company is going to be charging 0.55 for every mile. So 0.55 M, if we let M equal the number of miles. And we want to know when 0.55 M is going to be less than, it's kind of optional whether we put less than or equal to, what we're going to pay the first company, which is 35 cents per mile, so 0.35 M plus $10. Now, let's just assume that we're going to calculate it for one day rather than for both days of the weekend. It didn't really specify. But if we solve this, then I would need to subtract 0.35 M from both sides, which is going to give me a positive 0.20 M, or I could leave it as just 0.2 M, is less than 10. So divide both sides by 0.2. That's positive, so I don't need to do anything with the sign, the direction the sign's going. So 10 divided by 0.2 is the same thing as 100 divided by 2 if I multiply both of these by 10 to get rid of the decimal, which is 50. So if the mileage is less than 50, the second company is going to be better. After 50 miles, paying the extra amount per mile, over here paying the $10 per day, here the extra amount per mile is going to override that extra $10 and turn out to be more. So if John drives less than 50 miles per day, the second company will cost less. Okay, so that's the only difference between solving linear equations and linear inequalities is just on that last step that you have to make sure that you're going to turn that sign around. You need to be able to determine, you need to be able to turn the problem around so that if you end up with 5 is less than x and you need to put the x first, you know that means x is greater than 5. And you need to be able to put those inequalities both in terms of graphing them on a number line and putting them in interval notation. And that's it. See you later.